Hello, and thanks everyone for having me. There's some familiar faces in the crowd there, which is quite nice to see. And we've had some great presentations. In particular, the last one where Dennis and Toby were talking about using AWS, this first part is going to be very interesting. So I've actually split this into two areas, and that is how we can actually spin up an awesome Ansible lab. And then using that environment, we're going to look at Ansible playbook, performance, and bottlenecks. Okay, so for those of you who don't know me, I've had a lot of pleasure working for a variety of different companies. I can see a lot of people here from Nomura, either currently or in the past. There's some various bits there about my background, and in the bottom right-hand corner are my LinkedIn details. So if anyone wants to contact me later, you can use that. The bottom line, I have a reference to Dive Into, and this is my own personal endeavor. The course Dive Into Ansible is the latest version of my Ansible publication. So this was originally launched in 2018 as Mastering Ansible with Pact, and it's now been refreshed as Dive Into Ansible. It gets good reviews, good feedback, and I've made some great connections through this. The content that we're going to be going through today makes reference to what is actually taught in the course, but I've also actually brought in some new specific content for this London Infrastructure as Code presentation. As I said, the presentation is split into two parts, so there should be something for everyone here, regardless of your experience with Ansible. Something which would happen, and some of the feedback that I actually got from the first version, as part of that version, I provided a VirtualBox-based lab. People would download these VirtualBox images, they'd set them up. It was quite tedious to set up, and sometimes people would actually fall at this hurdle. Every now and again, I would get some feedback saying, why don't you just use Docker? Which on paper sounds great, but the standard container model doesn't really fit Ansible that well. Container will generally run one process in most cases. It's not an entire OS stack. And in Ansible, there's a mixture of things that we would rely on and we would typically use. So, for example, you would have SSHD running. You'd want to have your SSHD configured, and you'd want some of the common OS components, such as systemd, so that you can control services and really play about with Ansible. So for the new version of the course, I spent quite a lot of time building a lab environment using containers, but mimicking a real operating system. So having the common components that Ansible would actually need, like SSHD, but keeping it so that it's very, very quick, so that it can actually be set up. It's built with Docker. When you actually use this, you get an Ansible control host, you get 6 Linux machines, there's simplified SSH key configuration, and all of these systems you're able to access as terminals from your browser. And I'm going to set this up very, very quickly, and then we'll actually use this for the second part. And in that second part, we're going to look at Ansible performance. We're going to start with the defaults and how some very simple tweaks can be made to improve performance. We're going to look at Ansible pipelining. Ansible pipelining is a great feature. You can dramatically improve performance, especially where latency is involved. We're going to take a look at the asynchronous functionality. Again, this is a great feature of Ansible, but it's one that's often difficult to get started. So within this, we're going to go through a complete recipe that you can actually use. If you ever do need to use asynchronous functionality, you can use that. Alternative strategies such as free and the use of batching for when you're rolling out your production changes. I'll paste these links in the chat. And essentially, the lab environment that we're using is at that first link, and all of the examples that I'm actually showing here are on the second. So I'm just going to switch out and bring up this first one. Okay, so this GitHub repository is the lab that I'm actually talking about, and you don't have to be using the course to actually use this. It's completely open, and it's useful both as an Ansible lab or if you just need a quick and convenient lab for anything else. So what I'm going to do, I'm just going to grab that and grab the HTTPS link there. There is a detailed README with this, and it's got all of the instructions. There are some caveats and some things to be aware of. If you're running Windows, there's some tweaks you actually need to do to the configuration, but all of this is actually detailed. So what I'm going to do, I'm going to go to my terminal, and I'm just in my standard home directory there, and we'll clone that. Okay, and within this directory, we've actually got a .env file. So if you edit this, there's 2 lines that you actually need to change in this. You need to put the path to where you actually clone this, and /config, and the equivalent again, but Ansible_home. And with those 2 done, at this point, you could actually just run the lab with a Docker composer. It's a Docker compose based lab, and you would be good to go. I'm going to show one more step here, which I don't actually cover on the course, and the reason being, when you're presenting a training course on Ansible, it's actually good to go through SSH and actually show that and show SSH working. So what we can do within the lab environment, there's an option where you can actually fast track the creation of SSH keys. And what this will essentially do, I've just got a couple of slides to show this. What this will do is we will, as part of the config, we'll create our public and private key pair. And as the lab environment starts up, it's automatically going to add that public key to the authorized keys file on all of those systems. And we should, with this being done, have passwordless connectivity straight off the bat from our Ansible control host, which is Ubuntu-C, to all of these guest machines as either the Ansible or the root user. So I'm going to go back to the terminal, and we go into that config directory. There's a couple of files here. These quite simply have the user you want to create, whatever password you want to use, and what you want to assign as the root password. So you can change those if you wish to. By default, they are just simple. This is a lab environment, so these are just set to a password. But what I'm going to do is create the SSH keys. So within that config directory, I'm going to do a SSH keygen -f, and it's the same format, but it's guest_SSH. Just accept the defaults for that. And if we look, we've actually got these 2 here, and I'm going to copy these for the root user as well. Okay, so we've actually got these ready to go, and I'm going to go back a directory, and I'm going to do a docker-compose up. Okay, great, and that's it. And with those small steps done, you've got a fully fledged working Ansible environment. So now if I just go to the browser, with that running, you can just navigate to localhost 1000, and you actually get this nice page. You can click through for your Ansible terminal. You've got access to your host terminals. And within any of these systems, if you actually run any kind of web services, you can actually access these via the reverse proxy as well. So what I'm going to do, I'm just going to log into Ubuntu-C here. And I'll just increase the font so that's easier to read. And straight away, we have a system, and that has actually got Ansible 2.10, the latest version. The second link, which I actually shared there, is for this actual code base. So I'm just going to capture that, and I'm going to clone this in this environment. And as we've got quite a few Brits in here, in the style of Blue Peter, these are the ones I prepared earlier. So in that first template directory, so just to actually show this, all of these hosts, you can actually ping straight away. They're working off the bat, and we can actually ping the CentOS ones as well. And let's just check those SSH keys. CentOS 1 minus our root. Set that, and that's actually connected as expected, and it's connected through as the other user. So we're in a really good spot there for using it with Ansible. We haven't had to actually faff around with making any of the, configuring our SSH keys. It's a great environment for quickly getting involved. And in this first 01 template directory, I've got a base example there, which is self-encompassed, which has an Ansible configuration file. It has an inventory. There's some directories for group vars and host vars, and there's an example playbook. So if you actually look at this and you look at the inventory, we can quickly test this out. Probably as a one-liner. You can actually see there that all of that is working. And if you are new to Ansible and wanted to actually get started with it, you can go straight in with the playbook. It's documented there just to help anyone who's new to it start. And we've got quite a simple debug message. So if I just run this against that example playbook, it doesn't really do anything, but it just proves the point how quickly you can actually get started with it there. So all of the next areas are the specifics where we're going to look at the performance and profiling. So just to recap what we're going to go over, we're going to look at some of the actual defaults with Ansible. And these are things which are very simple and sometimes catch people out. A lot of the time when people are actually trying to understand or improve performance with Ansible, they'll go for the time command, they'll prefix with time. There's some great approaches you can actually use where you can get very detailed task profiling. So we're going to look at that. We'll look at forks and how that improves performance. Pipelining, as I mentioned, it's a great feature built into Ansible. It's not actually enabled by default, but you can get some significant performance improvements, especially where latency is involved. Asynchronous execution, which I mentioned, we'll look through a recipe of how you can use this, the freeze strategy, and serial execution. So let's start off with this Ansible defaults. So again, every one of these directories is self-contained. They all have the inventory and an Ansible configuration file with everything you need. So if we look at this first playbook, it's very simple. We've implicitly said that we're not going to actually gather any facts. And we've got 3 tasks in there, which each of them are just sleeping for 5 seconds. So considering that we're not actually gathering any facts, give or take, you would expect this to take just over 15 seconds. And I am going to actually use the time command on this. And let's run this and actually see. Okay, so you'll notice it's actually run for 5 initially there, and then it stopped, and then we actually get the 6. And when it actually hits again with the next 5, 1, 2, 3, 4, 5, then it finishes. And again, you've got the 5 seconds here where it's actually going to do the initial, and then it actually kicks in with this last one. So what we would have expected off the bat there to take just over 15 seconds has actually taken 36. So before we actually go into the why on this, what we're going to do is we're going to go into the next, and I'm going to show you how you can actually profile your playbooks in a better way than actually using the time command. And this is actually quite simple. We've got this callback whitelist. So callbacks in Ansible, they allow you to add additional functionality. And here we're using the Ansible collection, Ansible.posits, and we're using profile tasks. And again, it's the same playbook as in the previous one. It's just got a different name. And if we run this now, you'll see you get some good information. Straight off the bat, it didn't actually run any of the gathering facts, so this was quite quick. And then within this one task, you'll actually see this. So that took 11 seconds. Next one will take about the same 11 seconds. But you'll actually see then in this column, okay, so that took, yeah, just under 11 seconds, and we've been 22 seconds in total. And all in all, that was 33 seconds. So the reason this happened, and the clue, is actually in the name of this one. And I did see that in Dennis and Toby's presentation, one of the items that they actually tweaked was the number of forks. So what actually happens by default, Ansible will use 5 forks. And on this, our inventory, our lab environment, has 6 machines. So we've got CentOS 1, 2, and 3, and Ubuntu 1, 2, and 3. So what's actually happening, because that forks by default is set to 5, it is actually running those 5 tasks, and it's waiting. And then when that actually completes, it's moving on to the next one. So with that said, if we actually run this now, you'll see that this is actually running more towards the way we would actually expect it. But by default, I think that forks value is quite low. You can increase this, and naturally this is going to vary depending on the actual resources that you've actually got there for your systems. But you know, at the end of the day, I'm running this year in a container environment, and it's absolutely fine with this. So people typically scale this. I think in the last example, it was either 20 or 30 what we actually saw Dennis and Toby setting that as. So that's that's a nice and easy change for improving performance with a small amount of hosts. Next up, we're going to look at pipelining. So with pipelining is a functionality which is in Ansible, and it's not turned on by default because mostly on older systems, sometimes default parameters in the sudoers file can cause incompatibility. So I referenced this. It's a good one to look into, but it's one that you really do want to have some thorough testing with before you turn this on by default. And you really see the benefit of this where latency is involved. So if, for example, right now, I ping one of these other systems, because we're running in this lab environment, there's literally no latency between any of the guests which are here. So I have this script, and it's using the Unix command tc, and we're just going to inject some latency there just to actually slow things down a bit so we can see how pipelining helps. I'm just going to run this. And just the password there, which is the default. And now if I actually ping Ubuntu 1, you can actually see that the latency there has changed to 100 milliseconds. Let's have a look at the playbook we've got here, which is called, multi-gather facts. And what I've actually done here, so we've got gather facts as false, but for those who are not aware of this, when Ansible actually gathers facts on a system, what it's using is the setup module. And to simulate a bit of workload so we can actually see this, I've got the setup module running 10 times, just repeating, so that we actually can see the impact of this. So we've got our latency turned on. And let's run this with the multi-gather facts. And from experience, when running this, so it's going to get to 10. And from experience, you're typically waiting around about 35 seconds or so for this by default on this example. Okay, so that was 36 seconds there. And if we go into the next revision, and we take a look, in our ansible.config, we quite simply have got this extra section for SSH_connection, and we've turned the pipeline into true. So just to give a little bit more context on what's actually happening there, by default, when you run anything in Ansible, the typical steps that it will actually go through, it's going to generate a Python file for the modules with the parameters that it's going to use on the remote. It's going to connect via SSH. It's going to create a temporary work directory. Then via SFTP, it's going to copy, those generated files across. It's going to execute them. It's going to clean it up. Again, all of this is using SSH. And then it's going to get the output, again, via SSH, via standard out. When you turn pipelining on, it is essentially using SSH in a more effective way. So it's going to generate that module. It's going to connect via SSH to the remote Python interpreter. It's going to send that context across, execute it, and get the output straight back. And you'll see here, it's one of those ones where if latency is involved and your systems can actually support this, you can get a tremendous improvement in performance. So even visually looking at that, you can actually see that that's going a lot quicker than we actually saw on the previous attempt. And there we go. So we've taken this down. The previous attempt was 36 seconds, and we've now taken this down to 17 seconds. And I've got a script here, which I'm just going to run just to actually turn this latency off. And again, if I check my lab again, okay, that's working as expected. Okay, next examples. So we're going to talk about asynchronous execution next, and I've actually broken this down into 5 different examples. So first of all, let's have a look at how you would actually use asynchronous execution in Ansible. We've got some simple tasks here. Again, we're using sleep, and I've actually commented this one so that you can actually look at this for reference. But we're waiting for up to 10 seconds, and we have poll set to 0, which is literally fire and forget. It's going to immediately move on to the next task without waiting for a result, and it will run to the end without checking back on any of the asynchronous tasks. Now, all of these have 5 seconds by default, but this one here, task 4, is actually set to 30 seconds. So if I run this now, you can actually see there it's flying through, and it did all of that in 7 seconds. But we know logically that we had tasks within that for 30 seconds. It hasn't completed. It's not really that useful as it is at the moment, but there's a lot of potential. And if we actually have a look, you can see that these are actually running still in the background. So they will continue to run, and that will eventually time out. Let's have a look at the next revision and see how we can actually start making use of asynchronous execution. So slight change to this one, and what we're actually doing is registering the information in result 1. And right at the bottom, we've got 2 examples of how we can actually show that. So again, I'll run this here. And again, it will finish very, very quickly, but we've got a little bit more the information we need, specifically this Ansible job ID. So I only showed it for result 1, but you would have it for every result. Into revision 9, and if we had multiple asynchronous jobs running, we need a way of being able to actually capture all of those job identifiers. So if we actually look through this, right at the bottom, there's some a Ginger 2 sample here, which you can actually make reference to. And I just need to go to the top actually to show something else to explain this. We have a jobs ID list. It's actually, by default, it is empty. And what we're actually doing is using that output that we actually showed. If it has an Ansible job ID, what it's actually doing is taking the current array and it's essentially combining the array. So it's adding this to this value. Otherwise, it's just treating job IDs as it was before. And we've got a with underscore items there for each of the results. So 1, 2, 3, 4, 5, 6, which tally up with each of those. So if we run this now, you can actually see there, as it's actually run against each of the hosts, we actually have the relevant job IDs. Something I just wanted to note before we go on there, I have limited this with the when condition in each of these, just to actually keep them quite lightweight for now. That's why you only actually see 1 job ID per host. Okay. Next one, as the name implies, this will actually show you how you can actually, rather than it just exiting as the asynchronous job is running in the background, here we have the logic for how we can actually wait. So we're using that information that we've actually captured, which are the job IDs, and we're using this asynchronous underscore status module to wait for each particular job ID. And quite simply, we have with items to pass in all of those job IDs as the individual job ID. So this here, will run, but rather than exiting this time, we'll see that it's actually waiting. Now, if you recall, the majority of these, they just had a 5-second sleep. So there you can actually see that those ones have actually completed. And within 30 seconds, so 30 seconds in total, we should actually finish that last one, which was Ubuntu 1. There we go. Okay, so all in all, that was 41 seconds. Now that's the premise of asynchronous. You've actually got a recipe that you can use there, and you can apply that for using asynchronous execution in your own playbooks. But I just wanted to show on this. Previously, for all of those playbooks, I had that when condition, which was limiting it to a specific host. So we weren't actually running that much in the way of workload with the asynchronous jobs. In this one, this has actually been taken away. So every task is actually going to run against all 6 of our hosts. And this is going to actually put this lab under a little bit of pressure, but it does help you to actually see how you can actually use this and essentially run many jobs asynchronously from Ansible. Okay, so now we've got exactly the same playbook. We've got all of these job IDs which are there, which are running. And again, if we wait for this, we should see all of these come through. So some of the earlier ones have completed. Okay, great. And that was done. So again, we scaled that and we've got very good performance for all of those in the background. Next up, the free strategy. So by default, when you're using Ansible, it is using what is known as the linear strategy. So when you have all your tasks, it's going to run against the first task. It's going to wait for that task to actually complete, and then it's going to move on to the next task. So if you had a particular target which was slow on that one, that is going to then hold it up before it moves on to the next one. It's a very good strategy by default to have, because sometimes people will actually build their playbooks and then they have dependencies on other tasks. But if you haven't got that, there's an opportunity for performance improvements. So if we actually look through this, it's a very simple change. You actually just put the strategy is free. And what I've actually done here to show this is we have added in some essentially a sleep, which is variable for each of the hosts. So CentOS1 is going to sleep for 0 seconds, and this is going to build up gradually with Ubuntu free sleeping for 10 seconds. As I run this, the good ones to actually watch are CentOS1 and Ubuntu free. And like I said, rather than it actually waiting for each of these tasks to complete. CentOS1 in this case will complete on this, and then it will move on to the others, while all of the others gradually work through this. First one here is just a debug output, just to actually prove that sleep that we're actually using for each of these. And the way I'm making this sleep variable, I'm taking the position that they actually appear in the inventory and converting that to an integer and then just timesing it by 2. So let's run this. And like I say, keep an eye on CentOS1 and Ubuntu free. CentOS1 being the fastest, Ubuntu free being the slowest. Okay, you can see that CentOS1 has pretty much zoomed through and it's already completed task 6. So that's there. And the others are now in various states of task. And as this completes, you'll see the others will get through and Ubuntu free will be the last one to complete. Okay, so Ubuntu free is on task 3 at the moment. Task 4, so it's another 20 seconds. Task 5. And task 6. Okay, so that was the strategy. And the last area is just going to show on this. We've talked about performance and bottlenecks. Something else which is worth actually knowing about is the serial nature, which you can actually use in Ansible. So with the serial nature, we look at this first example. What we're actually saying here is we want to execute this against, we're using a serial of 2. So this is going to execute in batches of 2. So we have 6 machines in our inventory here. So this is going to work against CentOS 1 and 2, CentOS 3 and Ubuntu 1, and then Ubuntu 2 and Ubuntu 3. Let's run this. Okay, so yeah, we have CentOS 1 and 2 as the first batch. And then only when that's complete does it then start on the next one. So CentOS 3 and Ubuntu 1. And lastly, we have Ubuntu 2 and Ubuntu 3. So if you're rolling out changes in production, this is very useful. You can actually use serial in different ways. So in this example, rather than actually having a set number, we're using a list. So we're saying initially, we actually want this to run against 1 target, then we want it to run against 2 targets, and then we want it to run against 3 targets. And if we run this, we'll see this in action. We'll kick off with CentOS 1 for all of the tasks. And then you've got 2 and 3. And last of all, you have Ubuntu 1, 2, and 3. Okay, so whilst that's great, we touched upon the subject in the previous presentation of dynamic inventories. You may have a dynamic inventory for your estate, which will scale accordingly to your environment. And in this case, that example, you don't want to be updating that as your environment goes up or down. So if we actually look, a nice feature of the serial functionality is that you can actually use percentages. So here we're actually saying use 16% of our inventory, then use 34, and then use 50. And these percentages, they equate to what you actually saw there previously. This will actually, in our case, it will do 1, 2, and 3. But just to prove the point there, if we run this, you can actually see that working. And the last ones, you went to 1, 2, and 3. Okay, so that was that from me. Hopefully you enjoyed that. If you actually like what you saw on this, the course, as I say, these are actually sections which I've taken from the course, and I modify these accordingly, and change them for the purposes of this presentation. But there's a lot of material, and as I say, even outside of that, that lab is available and it's open for use if you think that might be of use. Just going to stop sharing that. Was there any questions on the content that as we were going through? Oh, and by the way, yes, I will paste that as we're talking now. I will actually put that discount code straight in. I will log on and do that. And I've got a discount code where essentially I can do it for the lowest price available. I think from memory, I have to check it, but I think that will work.
Nice one, James. Yeah, you've got your eye on the queue. So yeah, if anyone has any other questions, I think there's a couple of ones that quite like the lab setup. So I know you're going to share it anyway, but if you could just pass me on the presentation.
Sorry, yeah. I said I was going to put this in. So here's the actual, that's the lab environment. This is the code for the, this is the examples for the presentations.
Yeah. I mean, I'm going to have to watch that again, I think, some of that stuff. But I can see the thing is, it's when you scale. It's not the 5 and 10 servers. It's the 500 or the 2,000 or 3,000 where it actually makes a massive difference.
And I've just seen that question come up about mitagen. I think if mitagen is the correct pronunciation, I'm not too sure of it. But again, mitagen is a brilliant option, and I think for a long time there was a lot of people who had preferences over the use of mitagen rather than pipelining. Pipelining has improved, and it's continued to actually improve with releases of Ansible. And I think in some cases there may be some benefits to actually using mitagen, but generally pipelining seems to be the one which is more favorable. Interestingly, when I showed the strategy bit, the free strategy, mitagen is actually classed as a strategy. So you would, the way I actually showed there, you implement this as a strategy. I complete honesty on that one. With the rule of thumb, I don't actually know. Whenever I'm actually doing that, if I was doing it, I would try it out with simulated examples. Like I actually showed, if I had real examples, great, I would try it, and I would have one window, running something like htop at the same time.
Nice one. Oh, is there another question there from Salan? Any rule of thumb to provision a control host? How many cores, memories per amount of time.
Oh, yes. Yeah, so that's what that's the question I was actually referring to there. What I would actually do is it's an area that you just constantly need to actually monitor and keep an eye on, and try out simulations.
Nice one, James. I'll share your links tomorrow.
Thank you.
Same for you, Solomon. I just want to say to everybody that's left as well, if you enjoyed the talks, or feel free to publicize it. Feel free to share it on LinkedIn. Tell people that you had a good time, that you learned something new, and then you can pass that knowledge on to someone else. A lot of effort goes into all of this stuff, and it's great when we get some good feedback. So yeah, if you could do that, that'd be, I'd appreciate it as well.